amateur astronomers. They're mostly the general public. So a lot of the stuff that I'm going to tell you is I think you may have seen it already, but we'll see how it goes. We'll see how it goes. Now, shameless plug for the Sprucewood Star Party. It was wonderful. Please attend next year. It was great. Really enjoyed it. The seeing, the camaraderie, and the events were wonderful, and it's now a dark sky site. So the Harvest Moon Festival is next weekend, and they have an educational component to it. So Dustin Mimco asked me to do something, so I thought I'd do it on the moon, and I'll probably get some scopes set up. Last year when I was there, I had the moon, Jupiter, and Saturn were conveniently lined up in a row on the horizon. And I had about 100 people look through the scopes and look at those flat areas on the moon and say, gee, is there water on them? And we'd have discussions about that. And it was great fun. So this is an annual fundraiser that they have. And they get some good acts, and it's quite a bit of fun. Well, why did I get involved? Well, it's because I like observing the sky. I wanted to be an astronomer, but ended up being a family doctor for 45 years instead. I didn't see a pathway to that. I don't know, how do you get to be a professional astronomer? I really don't know. But it's fun being an amateur. Most of these pictures are mine, a few I borrowed. And the moon has eclipses, which are a fascinating thing. And the moon is great to look at, but do we need the moon? Yes, we do. This is a daytime occultation of Venus from a few years back, and it was quite fascinating. Now, this guy violates a lot of laws, and I wonder why the physics police didn't arrest him. And I think he also violated some quantum physics as well. And because he almost stole the moon. But if he did steal the moon, would we miss anything? Would there be something to miss? Well, these are the basic facts about the moon. Its distance, its temperature, its diameter, its volume. 45 moons would fit inside the Earth. Its gravity is only 16%. And it has no atmosphere. And its day is the same, almost the same as its orbital length. But there's some interesting facts and there's some of them that are very important for us. It's our only permanent satellite. It's the second densest satellite. And it shows almost always the same side to us, although because the moon's orbit is slightly elliptical, it has these what are called librations, so you can see sometimes past the edge just a little bit. And I've always fascinated that the moon's surface is quite dark. It's as dark as asphalt. And it has the same radial diameter as the sun. And the moon was originally thought to be 30,000 kilometers away. It's retreating from us at 3.8 centimeters a year, so in the distant future, annular eclipses will be far more common. There are moonquakes, and they're quite small, and there's water on the moon, and that can be argued. If they find a lot of water on the poles, then that's great. If there's not much water, then that could be trouble. And I found this fascinating. The moon dust smells like gunpowder. And I don't know what that means, but it does. But number 12, I think is the most important part. The moon stabilizes the Earth's orbit. And it keeps it at 23 degrees or so tilt. And if it wasn't, we'd be like Uranus and tilted all over the place. And life as we know it wouldn't be the same. And we all know about the tides. The difference in gravity this is closer to the moon than the surface. It bulges. This is further, so it bulges. And I'm told that the Earth itself bulges slightly as well, but not nearly as much. And the moon's orbit is like a spinning top. There's a wobble to it. And the wobble takes 18 and a half years, or 222 lunar days to go around its complete circle. And this was found by the Babylonians through astute observation, which is more than most of us do, very astute observation. But the moon is necessary for how we survive, but the fascination with the moon isn't based on that. It's been around for a long time. I'm fascinated with crescent moon, and I think Stan gave a talk on capturing early crescent moons last year sometime, or was it 2 years ago? But it was quite fascinating, and I caught one nice and early, so I quite liked it. Now, what does the moon mean to us? Well, in almost anybody's culture, it means a huge amount. In Google, there's 185,000 music tracks with the word moon in it. I don't know if it's because it rhymes or we have a deep fascination with the moon. And here are the top 6 stream tunes. Bad Moon Rising, Talking to the Moon, Fly Me to the Moon, Moonlight, Man on the Moon, Walking on the Moon, and Running Out of Moonlight. Those are the top 6 stream songs about the moon. But our fascination goes into prehistoric times as well. Venus of Mosul. It's thought that there's 13 marks on this probably horn, which may represent the 13 lunar cycles in a year. Thoth. I don't know if you have favorite Egyptian deities, but he's a great one. He was associated with the moon. And most ancient cultures have this. This is Artemis, and she's not ready to take off yet. She was prominent in Greek mythology, and there's, of course, a Roman, I think they used Diane for the Romans. And there's a whole bunch of other ones that cultures that have a moon goddess, a moon reference. Chinese, Aztec, Roman, Polynesian, and ancient Egypt has been mentioned. And in Inuit culture, there's a Alignac is there. I don't know much about him. But does the moon figure into our current religious beliefs? I've read that the sighting of the crescent moon in Islam is the start of the new month, and I know that it's. I know it's used to time the start of Ramadan. I've worked with Islamic medical students, and they're big on all this kind of thing. And Easter. Easter is a movable feast, and it's the first Sunday after the full moon that occurs on or after March 21st, which is the spring equinox. And this is an old calendar from way, 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 way back. And there is a papal astronomer in there to figure out the dates of what they call movable feasts. However, Anaxagoras didn't believe all that. He was exiled for believing the moon was a rock and it was lit by the sun. He figured eclipses had something to do with shadows. And that's was reason enough to exile him. The Saros cycle, now this doesn't, doesn't show up very well, but this is something the Babylonians wrote, and they knew the 18-and-a-half-year cycle of eclipses, and it's due to the wobble in the moon's orbit. But they'd figure it out just from astute and careful observation and writing everything down. But why don't we just go to the moon? And not everyone believes this happened. July 20th, 1969, I was watching a Motorola black and white TV and at my Baba's place. And as soon as Neil Armstrong had stepped off the ladder, my Baba knew it was a fake because politicians are in it for the money, and that was all set up, and that was just designed to get money out of us. And she's been long gone now, but there's probably others that might believe that as well. Now, I think before Neil Armstrong, I think it was more fun going to the moon. I think he spoiled a lot of things, and as this slide shows. And I know some people have odd beliefs about the moon, but I also found 7 unusual myths about the moon. Lunacy, and you know, the people in the emergency room talk about, oh, it's a full moon tonight, crazy people are coming in, but that's really not true. It just, I think the whole thing is random. Aliens inhabit the moon. I don't know where that came from. The moon controls fertility. The Assyrians believe this, and I think a lot of other people believe it. Statistics really don't show that. The moon is a hollow spacecraft. Well, that sounds like a great science fiction movie theme. And we never really went to the moon, as I mentioned previously. And this little fact I wasn't aware of before, in 2002, Buzz Aldrin punched a fellow on the nose who said that. And he ought to know. Apparently he wasn't charged either. I don't think they would have dared charge him. Whoops. The Nazis had a base on the moon. I don't know where that came from either.
There's a documentary movie.
Oh, what's that?
Yeah, called Iron Sky.
Oh, okay.
It's a bad sci-fi.
Well, that sounds more dangerous, but a rabbit dwelling on the moon, that's a little more benign. I think I could live with that more easily. The real thing, I think, is more memorable. And this is one of the famous pictures from moon landings. And if you look carefully at that picture, he's got moon dust all over him. And I've read that the moon dust is kind of nasty stuff. It's like tiny little shards of glass that dig into everything and cut into everything and wreck your spacesuit. Who knows how much a spacesuit costs. The other thing I've heard is that they're working on some sort of electrostatic repulsion system to try to repel those particles. I hope it works. We'll find out in, what, 2 years, 4 years, whenever that event happens. And the thing about going to the moon is you get unexpected benefits that you wouldn't have gotten otherwise. Bill Anders' famous Earthrise picture, and this is a wonderful, wonderful picture. It just grabs your attention and holds it. It just makes you think about the moon, makes you think about the Earth and all that's in it, and that says a huge amount. Now, what about us back here on Earth? Sheila gave me permission to use a couple of her pictures, so I'm not stealing them. And this is a sequence of lunar eclipse that she very nicely did, and has the foreground done up quite nicely too. This is one I did, but it's not so good. This is Casper, Wyoming, August 17th. Was it 17th? 16th? Anyways, 5 years ago. And the moon subtends about half a degree, and it moves its own diameter every hour, and that means every 30 days you get a month or a month. And that's about the same diameter as the sun, depending on which part of the node it's in. And if you get a chance to go down to Texas or Mexico in 2024, please take it, because the pictures are great, but the event itself is kind of overwhelming. And I filmed myself, put a little camera on the tripod during the eclipse, and I did exactly what they said I would do. I would rub my arms as soon as totality started. And I rubbed my arms because I was getting goosebumps all over the place. As soon as totality occurs, everything went goosebumps, and I started rubbing. And that's kind of what they say. So if you get a chance to see a total eclipse from a good location, take it. And this is just after totality. Also went to an annular eclipse in Albuquerque, and it was a huge event, and the Park Service there organized the whole thing, and it was great fun. And no, I didn't get Bailey's beads with that. This is the picture the Washington Post ran of me for some reason, because I was the furthest traveler to Albuquerque, and came all the way from Manitoba. Why would anybody travel so far to see an eclipse? Because it's fascinating. There's something about it, and I just loved it. Now, let's leave reality again. Science fiction. Well, in our present day, it's kind of made science fiction more difficult. Because H.G. Wells could have all kinds of creatures on the moon, and somebody could land there and have great adventures. But now that's quite a bit more difficult. This is 1929, Fritz Lang, Woman in the Moon. And it was commented on by several people that for 1929 it was done very realistically, and considering their knowledge at the time. This one isn't as realistic. How they got the flag to stand up on the moon, I don't know. And this one is downright silly. Now, and I think Neil Armstrong really spoiled a lot of stuff, because I think they had great fun, and they didn't have to deal with reality as much as we have to now. But there are some movies, 2001: A Space Odyssey, and Apollo 13, and others which were quite good. The moon movies, there's a huge list of it, which you can't read because it's too small, but with the moon as a theme of the movie, and there's likely many more. But there is a fascination with it, and people go to see it because we're fascinated with the moon. It's just getting harder and harder to make a good movie about the moon, because previously you could get a surveyor's transit and just stand on the moon and start surveying it, but you can't do that now. So how do we preserve our sense of wonder about the moon, which I think is the whole thing? I've already mentioned going to see eclipses, annular eclipses, lunar eclipses. I think those are wonderful things to do. But the simple thing is just to go outside and look at it. This is another lunar eclipse. Sheila Luchar's images, which are wonderful. Moonlight on the water. That's great. The moon is always there, and you can always find it. Look up and watch its phases as it goes eastward, about 12 degrees daily. When the viewing angle is close to the sun, it appears as a crescent. When it gets, as the angle gets more full, the moon gets more full. It's simple geometry, and I think for a beginner, just to go out and look at the moon and say, okay, it's a thin crescent, it must be near the sun. Oh, it's full, it must be away from the sun. And also figuring that it moves 12 and a half degrees every day, so that when you look at it one night, you go out the next night, it's over there. Or now it's near Jupiter. Or last night it was closer to Saturn. That sort of thing. And once you start noticing those little details, it enhances your ability to see it. And the other thing is, that picture I showed of moonlight on the water, that's a summertime thing. And in the winter, the moon tends to be very high up above. And I don't know if you can see this, but it's just where the tilt of the Earth, simple geometry, the tilt of the Earth puts it high up in the sky in the winter and lower in the summer. And I think it's great lower in the summer because it reflects nicely off the water and enhances its view a lot. Now, Stan Ranch, it was a couple of years ago, I think, suggested this Luna SoCal app, and I went and got it, and it's wonderful because no matter where you are, it uses the phone itself to get your latitude and longitude, tells you the sunrise, sunset, moonrise, moonset, and it's just so nice and easy to use, and it'll give you the phase of the moon, and as many details as you want or don't want. So if you're at all interested in the moon and not sure what to do, you can get this Luna SoCal app. You can go out and look at the moon, and I think that's a great place to start. And with that, I would like to thank you, and that's all I've got. Thanks.
Do we have any questions for Alan? Is there any questions on the chat? No? All right, well, thank you very much. So Scott is our guest on.
He is on, and we will bring him over momentarily here.
Okay, I'll just do it. I'll get that set up. So just while we're getting, set up, just a couple things again. I just want to thank the Manitoba Museum for joining with us and allowing us to use their Zoom account tonight. For those that have just arrived from Mississauga Centre, welcome. Welcome to joining us tonight for our, I see hands waving here. Put my glasses on, I can actually see most of you. So again, Mississauga Centre, welcome to the Winnipeg Centre. And in a few minutes, we'll begin our presentation from the CSA. And for those at the Winnipeg Centre, I just want to remind you that when we're finished with our guest speaker tonight, this Zoom presentation will finish, and there's a second account that you will log in to come back for our regular meeting, where we will also deal with the bylaws at that time. So just a reminder to our Winnipeg Centre members that when this is over, this Zoom meeting will close, and then we'll reopen under the other Zoom link that was sent in the invitation for tonight's meeting. So are we all set?
Yep, so we just need to stop sharing the first presentation in Zoom.
Okay, I'm just going to let Ed do an introduction.
Okay, yeah, sure.
All right, Ed.
Okay, thank you, Dennis. Well, good evening, everyone. And I'm hoping Martin get the pulse rate of an astronomer, either amateur or professional, really racing this year? Well, it could be something like, Elon Musk and Starlink. That could get your pulse rate racing. But the other thing that can get your pulse rate racing is the James Webb Space Telescope, or as it's affectionately known, the Webb. So I wanted to say we are very privileged, and I'm ecstatic that we're able to have Martin Bergeron join us from the Canadian Space Agency for a 1-hour talk on the James Webb Space Telescope. Just to introduce Martin, he is the Director of Space Exploration Development at the Canadian Space Agency. His talk is called the James Webb Space Telescope, Canada's Role in the Exploration of the Universe. And just one last final comment, Martin, I'm very glad that you're able to join us. It's been a journey to get Martin here. It actually started back in February of this year, and somebody that I know at the CSA said, we can maybe get a speaker. And so it's taken this while just to get our timetables together. So I think this is really glorious for us to be able to do this. And this is actually the first time that I've been able to see and speak with Martin. So that's it. And Martin, we're just trying to get our technology working here.
Okay, now just switch the audio over.
Okay.
That'll be good.
This is the cost we pay to not have to fly out here.
Yeah, but I'd like to share my own screen if it's possible.
Yeah.
Because
Yeah, for sure. Okay.
it's just that it's disabled. You'll have to enable my screen share.
Of course.
So with that, I'll get it started so we don't wait much while this is being done. So bonsoir, and good evening, everyone. It's certainly with great pleasure that I'll be walking us through one of the most amazing, at least in my opinion, engineering and scientific accomplishment of our time, which is the James Webb Space Telescope. In doing so, we'll take a look at the instruments. We'll look also at the science questions, some of the Canadian contributions to the observatory. Finally, I also want to say a few words to the institutions, Canadian Space Agency mainly and others, and the community responsible not only for the development of the Webb, but also at the Canadian Space Astronomy Program. So I'm all ready to get started, provided that I was able to share my screen.
Should be good now.
Like this, yeah, that's excellent. And hopefully now, you'll see what I'm trying to show. It looks it does. Okay, you all see that? Okay, so since 1990, and can you hear me well enough? That's good? So since 1990, the Canadian Space Agency has had a mandate to promote the peaceful use and development of space. So it's both to advancement of knowledge of space through science, and to ensure that space science and technology provides social and economic benefits for Canadians. So we support this mandate in a variety of ways. This includes space utilization, that is the use of satellites for Earth observation and communication, but also the science mission that look, for example, at the Earth's atmosphere and at the Earth's surface. We also work with science and technology to develop and foster the growth and capability of the Canadian space sector, both in academia and also in the industry, and also to inspire the next generation to pursue careers in science, technology, engineering, and mathematics. So main program elements include, and you'll see some of them now, the International Space Station, which is poised to be extended all the way to 2024 and hopefully further. Also the RADARSAT Constellation mission, which is an all-weather ice monitoring of Canada's waters, also used for disaster management, environmental monitoring, security, sovereignty, etc. to name a few. More recently, and also right on the topic of the previous speaker, is our Lunar Gateway orbital platform, or Gateway, whose contribution will enable us to add a Canadian sea and go all the way to orbit to the moon in the near future. So, last but least, is the Space Exploration Program. It includes our Canadian astronauts planetary science, planetary exploration, and what is the topic of today is space astronomy. So the CSA, of course, is not alone in defining the priorities and delivering on the space astronomy program. We're supported by what we call a Joint Committee on Space Astronomy, which is done in partnership with the Canadian Astronomical Society of CASCA. We're also coordinating our effort with the National Research Council, in particular the Ericsburg Astronomy and Astrophysics Research Center, located in Victoria, which is well known, and whose role is to coordinate the Canadian Ground-Based Astronomy Program. They also operate the Canadian Astronomy Data Center, perhaps some of you have used it before, which serves as a national archive for astronomical data, whether they're ground-based or space-based. Most importantly for us, the CSA is implementing its space astronomy program following the recommendations from the community. One such key driver is the CASCA Long Range Report, which they deliver every 10 years, which we support in its development. The latest that was issued was in 2020, and it covers the next decade all the way to 2030s. It provides the community viewpoint on the rationale and the primary science questions that should be targeted, and also make recommendations to the priority observatory that Canada could contribute to in the next decade. We see some of the key science questions, for example, how did the universe begin, how stars have evolved, what are the extreme conditions of the universe, and what are the planetary systems that could host, for example, life. Those questions you'll see are very aligned to the goals and objectives of James Webb itself. So obviously the James Webb has drawn a lot of attention since the beginning, and it was already identified early as an important contribution to the many questions that I've just mentioned. We'll take a closer look at that. So what is James Webb? I think it's well known from many people, but I'd like to refer to it as our flagship. Of course, we don't manage and own the spacecraft, but it's the flagship space astronomy component of our fleet. So it's an international collaboration between, of course, NASA, the European Space Agency, and perhaps not as well known even for Canadians, is there's a significant Canadian contribution. For us, it's a mission of unprecedented size and complexity in space astronomy. It is the largest single investment that Canada has made in space instrument, costing well beyond $200 million to develop the key instruments, but also to contribute to the operation, which we do, and to reap the benefit of the amazing science that we are known for. So just a few key elements. So it's a massive 18 hexagonal segment, 6.5 meter primary mirror. Webb has an impressive 1 milliarc second pointing accuracy, covering a wavelength range for those that understand the numbers from 0.6 to 28.5 microns. It was launched successfully on Christmas Day from Europe's spaceport located in Kourou, in French Guiana. And hopefully you've seen the launch. It was a very great picture, and even more impressive was the deployment soon after. Webb has since arrived at its final destination. We'll take a look at this, and it has started operating, of course, as July of this year. With the amazing early release observations. We'll take a look at some of those later on. I think it's time to acknowledge some of the key players, like principal investigator Dr. René Doyon from Université de Montréal, the project scientist Dr. Chris Willett at NRC, and the mission scientist, which is a resident at CSA, Jean Dupuis. So I think it's not fair to say James Webb came out of a vacuum. It builds on the shoulder of many previous successes, both internationally and also in Canada. So it's important not to construe that Canada contributed to Hubble shown here, but Hubble's successful launch in 1990 aboard the space shuttle. I don't know if it's me that got kicked out or if I kicked out. My apologies to everyone. Let's go back to please enable sharing again, and I'll be continuing. HST. My apologies for the technical difficulties. Let me know when I'll be able to share again. not opening it. Man, I still can't share the screen. It's okay. James Webb wasn't built in a day too, so they've got their shit. Okay, we got it again. Okay, let's wait. Thank you. Sorry about that. So as I was saying, obviously, as it builds on the previous success of Webb, even lessons learned. Hubble had significant cost overrun, but it was also a warning that space missions designed, they must be carefully planned and tightly controlled. So Hubble is very different from James Webb. It's quite different. It does not operate in the same wavelength domain. Webb is more than 6 times the light gathering capability. Webb is not in low Earth orbit. There are important distinguishers that actually make James Webb, which is not just a mere successor. It's really the next generation of space telescope. So talking about its location, it's one of the key characteristics in James Webb. It's an impressive 1.5 million kilometers or 1 million miles away from the Earth. It's in a locally stable point, which is called a Lagrange point. There's 5 of those around the Earth-Sun system. The one that's chosen is shown here, and it's the one that essentially and we'll see the benefits from that. Webb does not sit on L2, it actually orbits L2, and it's a typical hang-around spot for infrared telescopes. Why is that so? It's because they don't need to operate at low temperatures. In the case of Webb, it's below 50K, and it requires shielding from both the sun and also shielding from the Earth all at once. It's noted that the injection orbit, that is the launch, was so successful that it still has a significant fuel reserve, and it allows essentially for a duration of a mission that's going to go well beyond the 10 years nominal operation. So the full generation of astronomers can now plan to use the data from Webb. So we'll take a look at a short video. Hopefully it's going to work. If the lag is too big, you may not be able to see it. But so let's see if we can get started. It doesn't. Anyway, so as I said, the orbit of L2, so it orbits around the circle, and what's important is that the sun shield, which is made of, it's a tennis court size sun shield, it's quite impressive. It's constituted of 5 very thin, almost hair-thin layers that always essentially shields Webb from both the sunshine, which is a bit obvious, but also from the earthshine. So in the infrared, it's important to shield it also from the Earth radiation. And that's precisely what this orbit is intended to be. Okay, so a quick look at the instrument. They're quite complex. I'm not going to go into a lot of details, but it's a formidable observatory. It's composed of 4 primary science instrument assembly. So NIRCam is James Webb Primary Imager. It consists of, it covers essentially from the visible to 0.6 to 5 micron. There's 2 nearly identical, fully redundant modules. They point to adjacent field of view in the sky and can be used simultaneously. They split the light in some complex way, allowing essentially simultaneous imaging at 2 different wavelengths. It's quite complex. There's a wide field range, there's a narrow field range, there's broad filters, etc. It operates with a slit, without a slit, essentially very complex instrument. Let's take a look now at an instrument developed through a collaboration between the European Consortium and the Jet Propulsion Laboratory, that is the mid-infrared instrument, that's MIRI. It provides coverage in a mid-infrared wavelength, that is the much longer ones, and imaging can be obtained through 9 broadband filters. It also has a spectroscopic mode, which allows a low spectral resolution, though, but provides also a slit and a non-slit capacity of imaging. Then the third instrument, which is non-Canadian, I'll move to the Canadian instruments afterwards, but is the near-infrared spectrograph. Very versatile spectroscopic instrument, so it breaks the light into multiple wavelengths and operates in the visible 0.6 to 5.3 microns. It has a very high throughput, that's a very efficiency, especially for single object spectroscopy, but it uses fixed slits. Again, it's a very complex instrument with many modes to do it. It was built in collaboration with Airbus Industry and also Detector detectors system by NASA. So these are the three international instruments. Let's now take a look at the Canadian contribution. So again, it's not out of a vacuum. We built on our past success. Canada, it may not be known, but Canada provided the fine error sensor and the FUSE mission back in 1999 and demonstrated then its capacity to deliver a key instrument to James Webb. Also, early Canadian scientists were involved in a then name. It was called the Next Generation Space Telescope, not yet Webb, such as Professor Simon Lee of the University of Toronto, which is to this day still a member of the Science Working Group, and also people like John Hutchings, which is what became the FDS instrument PI. They were able to convince NASA to let Canada deliver this critical component. Also, there was a D-scope, so that's the FGS. We'll take a look again in more detail. And also there was a D-scope of what was then a Fabry-Perot tunable filter interferometer that the US wanted to do, but they actually D-scoped. And some Canadian scientists seized the opportunity, anyway, mainly, to raise to the challenge to use the mass and volume margin that was now made available in the D-scope instrument to propose a Canadian science instrument. They worked really hard and the concept evolved over time, actually now deriving to the newest concept. So it's only in 1996 that the international collaboration between NASA, the European Space Agency, and the CSA finally materialized. They are functionally independent, that is the FGS and the NIRISS, we'll take a look, but they were packaged as a single unit. Their combined dimension is roughly, as you see, a cubic meter, essentially a dishwasher size with a mass of about 80 kilograms. Making it a very expensive and complex dishwasher. The fines guidance sensor is a critical component of the proper functioning of James Webb as a whole. So for me, it's amazing that even NASA let us do such thing that's on the critical path. Every single observation that's being performed in James Webb needs the help and the support of the fines guidance sensor. So the primary purpose was to ensure pointing stability, but you can break it down into three areas. So number one, provide a whole field image to help find the area of the skies that need to be targeted. That is to determine the position of the spacecraft in space. Element number two, serve to identify the targeted area using a catalog guide star. So it focuses on a guide star once identified, and it helps maintain the guide star in a very tight portion of the sky. So it locates and tracks a celestial target. Element number three provides the satellite attitude control system with precise information to maintain the pointing accuracy, again, the 1 arc second, but 16 times per second doing so. So it remains steadily with very high precision on the specific target. So FGS is again a fairly not so complex, but an instrument with a primary mirror, 3-mirror assembly to collimate the light. For those that know the detector or are interested by this, it's a mercury cadmium telluride detector. It's about 4 megapixels, also closely visible to near-infrared range. It was built by Honeywell Canada, which was formerly known as. Now moving to the science instrument, which is the NIRISS, so the near-infrared imager in slit-lens spectrograph. It provides unique observation capability between, again, 0.6 and 5 micron that complements those available with the previous instrument, the near cadmium inspect. It's a very high efficiently all reflective design. There's only mirror surfaces. There's no lenses. It's provide a wide field imaging, a spectroscopy. So it's a very complex instrument with multiple modes of operation, using state-of-the-art grating prism combined, also called prisms, for spectroscopy, either at low resolution over a wide field, it's as much as 2 arc minutes by 2 arc minutes, to a medium resolution prism spectroscopy, which is optimized for application requiring extreme spectroscopic stability. It also has a set of filters that allows it to match those of near cameras. Again, it's a 4 megapixel camera with a mercury cadmium telluride detector. So what is shown on the right is one of the things you can deliver with the system. Because of its precision, it enables measurement of the relative brightness of the solar rotation. In this case, it's the WASP 96 BB, as I think is the star, the planet in WASP 96 is the star, allows to reveal the presence, in this case, of what is a hot giant, a gas giant exoplanet that's orbiting the star. So NIRISS was a contribution of, well, of course, the CSA, but also Honeywell International. It was also led by René Boyon, Université de Montréal, with also technical support from the National Research Council. So why doing this? Obviously there's some industrial benefits, but most important in my opinion is the system is now functioning, fully operating. But it enables, these technological contributions enable the Canadian astronomers to gain access to the amazing science that will be delivered by web. So there's a variety of access that's being given. There's the only non-competed one is the guaranteed time observation, which is giving to the scientists that help develop the primary instrument. So Canada gets 2 times 200 hours for this program. Also, Canadians have been very successful in competing in the case of the early release science. So that's not the early release observations, it's the early release sciences. With one Canadian co-PI being selected, but other Canadian collaborators have been selected. What's critical is the success that Canadians have had in the General Observer Program, so the GEO program. This was the first call, and you see that 14 Canadian-led proposals have been selected, and more than 70 Canadian researchers are actually collaborating on this. Overall, it's 5% of all of the web observing time that's on average will be dedicated to Canada for its contribution. It may sound as a low number, but if you make a fraction of how much we invested to actually how much the whole system costed, it's very efficient. Okay, now we're moving to the science and some of the science objectives. This one is on the early universe. So it's an amazing science that's unveiled because, well, James Webb is such a formidable time machine with unprecedented light collecting capacity and also the capacity to look very distant in the early universe. Part of the reason James Webb was designed to observe in the infrared is explained by essentially by the redshift that we are observing in the light. That is, the light is being emitted by distant stars and galaxies, and because of the expansion of the universe, essentially the expansion expands the light also as it reaches us. Wavelength shifts then from the visible light, if they were emitted then to the infrared lights as we see it. So ultimately, James Webb is tailor-made to be a time machine allowing to purse and look into the early universe. What I'm going to show next is one of the early release observations that demonstrate this capacity with a deep field. Most of you might have seen the image already. This is a massive galaxy cluster. The number identified there. It's so massive, and the location it has, it acts like a strong gravitational lens that bends the light that's coming further from it, and essentially bends the lights toward us. It kind of acts as a magnifying glasses, allowing to see very distantly in the background. So that was already identified in previous surveys, for example, through Hubble. But what you see in there, it's just amazing depth of the field, the curvature of the gravitational lens. It's just a beautiful image into itself. There's a lot of spectroscopy that can be done with this image, and a lot of information that can be inferred. Okay, another element of the science objective is galactic evolutions. So it's an important science objective. It's to study how they evolve, and how the matter in the universe essentially is organized on the large scales. It helps to understand the nature and the history of the universe. We need to study it so that we understand how matter organized and how it changes over a long period of time at different scales. A question can include, how and when did the first galaxy form? How did we end up with the large variety of galaxies that we see today? Also implies that we need a better understanding of the galactic structures and the impact of massive black holes that many of the galaxies have in their center. Galaxies are still merging and forming as we speak to this day. For example, our own local galactic neighborhood would be an Andromeda galaxy, which is heading towards our own Milky Way. Of course, it's not to worry. The impact is only billions of years from now. So what I've shown here also is another early release observation. It's the Stephan's Quintet, so-called, because there's 5 galaxies. NGC 7318 has 2 of them that are still emerging. A large collection of massive galaxies. One is merging. Another one, NGC 7319, has a very active galactic nucleus, rotating, also jet of gas that emits a lot of radio wavelengths. It's a very complex environment that really well demonstrates the ability of Webb to be able to look and to image galactic mergers. Just to notice that the 7320 That is the one on the side is much closer to us. It just coincidentally happens to be in the field of view, but it's not actually relating to the other galaxies. Third science objective is stellar life cycle. Stellar astronomy has been there for a long time. It's quite interesting, but understanding stellar birth and the early evolution of stars is much newer. That telescope used to peer deep into the dense and dust-rich environments need to be able to observe in non-traditional wavelengths. The visible light is essentially, the dust is essentially opaque to the visible light. And infrared as a capacity is not as diffractive as capacity to penetrate much deeper. So young star formation, such as this Carina Nebula, has very complex interactions between the stars and the interstellar medium. The details of how the star evolve and how they release some heavy elements that then get recycled into new stars that also get born is very complex on that. This is an early release image again of the Carina Nebula. It shows what's called the eastern edge. It's rotated. There's no up and down in space, but this is rotated. Typically, you see that to the east. It's the eastern edge of a much larger ionized bubble, but it's a great zoom. If you've seen the comparison to Hubble, this is much clearer, much nicer view of the same image being taken now by Webb. It's a highly ionizing region, so many of the stars emit radiation. Some of the gas gets essentially ionized, lose their electrons. They're essentially more transparent to light. And in some areas, well, you see the dust-rich being pushed. And in those areas of dust-rich element, maybe I should use the pointer, dust-rich element in here, you see many stars being forming at the same time. So it's a pretty good understanding of star forming. And it's really helps with the understanding of stellar evolution. Okay, that brings us to the last but not least, science objective of Webb, which in my opinion is one of the most exciting objectives, which is the quest for exoplanets. Since the first was observed, we now have thousands of those that have been observed, and every sort of star system that have been listed so far. This continues to expand every day. So it's one of the main uses of the James Webb Telescope is to be able to study the atmospheres of those exoplanets. So that's not as common. To search for the building block of life, potentially, if we're lucky, elsewhere in the universe. So primary method by which it's going to observe this, it's the transit method. I've shown you some image of the nearest instrument with the transit method. So essentially the planet orbits around the starlight gets dimmer, and essentially by characterizing the difference in the imagery with and without the planet, you can infer some elements having to do with the composition of the exoplanet atmosphere. So it's a primary method. It requires a pretty good, essentially, dimming of the star itself, so some method they use called colonoscopy that enables direct imaging of an exoplanet. This is what we see here. It's not one of the early releases, it's a very recent release. It's the first exoplanet image by Webb. It's HIP 65426 for those that know. It's planet B. It's about 7 times the mass of Jupiter. It's very far from its sun. And it's a very young planet also, millions of years and billions of years, if I understand correctly. So very interesting. So these are actually, the image of an exoplanet, which is critical. Finally, it's also important to understand that yes, other worlds also mean studying our own solar system. Obviously, there are ground-based, other telescopes. There's even missions that are being sent to those distant worlds in our solar system. But data with a different wavelength and also from different sources and an amazing resolution allows us to build a broader, fuller picture of the objects in our own solar system. This is such an impressive image of Jupiter. You see the auroras, you see the rings, you see diffraction spikes from even some of the planets or of the moons orbiting Jupiter. I think I'm speechless to see this amazing image. Hopefully you have appreciated as much as I did. So we're getting to the end of the talk. I'm just going to cover a bit more. Obviously, Webb is amazing. As I said, it's our flagship, but it's not our only space telescope. Currently, we have contributions, not necessarily leadership, but contributions. For example, on top right, it's the AstroSat, which is India's first astronomy satellite dedicated to studying high-energy objects in the universe, like young stars and black holes. So we did contribute detectors to this mission, to a detector that's ultraviolet imaging telescope. It's called UVIP. And thanks to the contribution to this science instrument, we now have the ability to compete for observing time on AstroSat. And we do that. We have calls systematically where we have Canadian scientists that can observe. They can access the multiple wavelengths from the observatory. There's X-ray, visible light, etc. The main mission was to observe high-energy activities in star system, etc. It's, again, fairly complex set of capacity. Then we can move to, it's not the involvement in the CSA is not so large in this one, but it's an impressive industry and academia-based system, which is the Bright constellation on the top left. It's the first space astronomy missions to be carried with nanosats. It's still in operation to this day. I remind you, it's been launched in 2013. Not all the satellites function. There were 6 initially. Only a few now remains, but it had the goal to learn more about the structure and evolution of the brightest stars. So you see the light collecting capacity is not that great, but for the brightest stars, they could look at, for example, precursors to supernova explosion. Canada was more than a partner, right? Actually, they partnered also with Austria and Poland, and we did provide support for both the design and the operations of the systems to this day. Finally, the trio is completed, and this one is only Canadian. It's called a NEOSat. It's the world's first space telescope dedicated to detecting and tracking asteroids, comets, and satellites and space debris. So it's kind of a suitcase-sized satellite that can really look very closely to the sun. So you see there's a fairly long baffle at the front of it, and that allows it to look more close to the sun than many other systems. So NEOSat sweeps the sky, observing satellites, space debris, and it's part of our Canada's commitment to keeping space environments safe. It can also reveal the presence of exoplanet, hence the astronomical link here, around distant stars, again using a principle of looking at the light intensity variation around stars that are due to orbiting exoplanets. Most NEOSat and Bright also were building on the most successful earlier, now the commission. And this is my last slide, so I'm completing my talk on this. It's of course, we have to look to the future. So what is it? We've talked about WEB, it's going to operate for a long time, but let's take a look at the future. One of the highest priority that the CASCA, the Canadian Astronomical Society, have proposed in the long-range plans is the CASTOP. It's called the Cosmological Advanced Survey Telescope for Optical and Ultraviolet Research, CASTOP. It's a proposed mission concept that would image the skies while we see ultraviolet as a blue and blue optical wavelengths. In a certain sense, it can be felt as our actual successor to Hubble. It's developed in collaboration with NRC CASTOP. We'll be operating close to the diffraction limit. It's a 1 meter size aperture telescope, so much smaller than Hubble, but the developing technology and detector capacity makes it still, they will cover a much larger field of view, about 100 times larger than Hubble. If funded, CASTOP will be the very first Canadian-led large space astronomy mission. Currently, there's both a feasibility study and technology development being supported by the CSA. Also identified in the long-range plan, Canada is positioned to maintain its world leadership in studies of cosmic microwave background. So the CMB, there's substantial participation in either or both. The CMB S4, which is a ground-based facility, and what is shown here is the JAXA, that is the Japanese Space Agency-led Lightbird mission in space. They target the cosmic microwave background in a very complex way. I think I won't even try to get to explain the out of my depth here, but it allows to fully exploit the radiation from the Big Bang, yet to understand the origin and the history of the current universe. So there's a key Canadian technology at the Art of Lightbird, which is also potential spin-off for quantum computing. We support again technology concept studies. And last but much smaller is the Ariel. It's a fairly large mission. It's an approved medium-class European Space Agency mission. Again, a 1 meter telescope, but it's designed to obtain precise transmission spectroscopy for a large number of transiting exoplanets. So Canada would not necessarily contribute a significant portion of it, but we are considering a small contribution that would enable Canadian scientists to be part of the Ariel consortium and have parity access to the data. These are not the only concepts we're looking into for the future. There are some other obviously down below. They cover a large variety of observatory type and observatory size. None of these concepts have been secured yet, but they're being fostered because what we want is to ensure that Canada can continue to strive for a bright future in space astronomy. So with that, I think I'm on time, and hopefully steer some interest. And I will gladly take some questions to the extent that I can answer them.
Thank you, Martin. Steve, we'll get a little bit of audio. I'm not sure if you can hear me here. Echo.
Oh, yes, I
Can
am.
you hear us during that day? Can you hear us, Martin?
Very well.
Oh, okay.
Hopefully, and it was so bad on my end too when I spoke. So.
Okay, yeah, no, it was excellent. We could hear you very well. Okay, so you said, Scott, there is a question?
Yep, there's a couple of questions here. One is about the orbit of Webb and the halo orbit, and if you could explain, if Martin could explain a little bit about the orbit and how it stays in the halo orbit.
Did you hear that, Martin?
Yes, but I'd love to be able to show the video because it's such a great. Let me try again to share my screen. I'm going to do this because the video is such much better than I could even try to show you the exact orbit. It's not a very stable orbit, mind you. So let's, of course it worked when I tried it at home. No, it's not. Give me a second. I think it's working. It's working. It's working. Okay. So you should see the presentation now. I should be able to go in the deck itself, and that should be now running. Okay. Maybe I will succeed. I'm trying too hard. Something too complicated. Okay. So you see, Webb orbits around L2 in a circular orbit. It's a fairly stable orbit because it's around L2 and there's a compensation of both the orbital mechanics and the gravity of the Earth and the Sun combined. So it doesn't require a lot of fuel to maintain. What's really interesting, and I'll start it again so you can see it again, is that this really enables the sun shield to be always pointing more or less towards the Earth and the Sun. So it serves to baffle both of those. So if the question was asking me what is the orbital mechanics that allow this to, I just don't have the answer to that. But this video shows a pretty well a complex orbit. First, it orbits around the full year, and of course, Webb cannot observe everywhere at any time. Have specific observation locations depending on when it is in the yearly cycle and its geometry to the Earth, the Sun, and the rest of the universe.
Okay, great. And there was another question here about the image of Jupiter. And there was something labeled Io's footprint. And the question was, what is Io's footprint?
Oh, okay. Yes. Okay, I'll show it again. I'll share the screen. Let me go back to presentation mode just a second. Because it's such a great picture. Let's take a look again. Okay, and hopefully I know the answer, but share mode. Okay, and share again. Okay, so yeah, that's pretty good questions for the Io's footprint. I certainly understand the spike here, the diffraction spike, because Io's is out of the picture. So it's not to be seen here. But that's a good question. I admit I don't know. So good. Can I take a real check on this one? yet that it's barely visible. It's, I would have to zoom. I think I see it at my screen, but there's no way you can see it at yours. Yeah, but that's what it must be. It's projection of the panel.
Does anybody in the room here have questions for Martin?
I have a question. This is really naive, but why a slitless spectrograph?
Okay, so yeah, there's many ways to split the light. Okay, and there's many ways. Of course, the most ancient one is the Newton's way. We use a prism. So you use a prism at different diffraction index depending on the wavelength of the light. The light gets curved differently as it enters the prism, and it separates. The white light enters in, and you get a different set of lights going out. Many of the spectrometers have been using a method essentially which uses a
Secret.
remove the unwanted light on your detector. So in one dimension you have the wavelength, in the other dimension you have the image. You have to construct it into in the case of the NIRIS, it doesn't need to use a slit. The next generation of system, there's many ways to do this. There's even interferometers use other ways also. But in their case, they use a combination of a prism and a grating, which is called a prism. So essentially, light gets separated, and they don't need a slit. Maybe my explanation is pretty not so good. I would need a diagram to give a better explanation. But that's the best I can do.
We have some more online questions here about that. Let's see. Ron McNaughton asks, the total web cost was way over its initial budget. Did Canada have to pay part of those extra costs, or did we do what we budgeted for?
Yeah, no, that's a great question, which I know. Because I cater more to the program aspects of web and its technology or its science. But no, indeed, what was the idea of a national contributions to a space program is Canada commits to delivering this, and sometimes whatever the cost. So it depends on the arrangement. In the case of NIRIS and FGS, once we committed and delivered on those, and which we did, yes, there were some overruns even in Canada, but nowhere near the significant overruns that we saw for Japan. So in the end, ultimately, things that drive the cost overruns is duration in time. Web has launch has been postponed and postponed and postponed. So we have to hit some of the extra costs due to that, but not in a ratio of cost increase that we saw for web overall. So, if you make a calculation, we expended $200 million roughly on a program that's now way above $10 billion overall. So I think getting 5% of observing time for such a small contribution is very significant. It's not to the initial ratio. I think we did better. Managing the budget.
I'll move on to online questions, but if you want to throw in those questions.
Any other questions in the room here before we go to online?
Okay. Graham W. asks, is L2 the first time this has been used in space exploration?
No, not at all. It's getting busy. Exaggerating. There's a WMAP that was there. There's Planck that's still there. It's a really sweet spot for infrared observatory for the same reason that for Webb. It allows to shield both the Earth and the Sun. It's also stable. Orbital mechanics is also stable. It's not so bad for dust, maybe an issue, but not so bad than other areas. We have experienced some first issue with the micrometeorites. It's part of the challenge of being out there in space, unprotected by the Earth's radiation shield, which you get in low Earth orbit. But the orbit is much better.
And that's actually the next question. Randy Atwood from Mississauga asked if you could provide any information on the micrometeoroid danger and how the one hit has affected its performance.
Not much. I can tell you that it has not affected much its performances. I saw some, not directly, but some of the engineers working with us saw some of the results, and And actually, at this point, it's not a concern at all. The question is, do we understand the statistics of micrometeorite impacts at that location with respect to size and frequency of micrometeorites? And that's what's not as well known. So, is this a one-hit wonder? Of course, something that happens will not necessarily repeat itself. So far, so good. And no, it has not significantly injured the spacecraft. There will be options if it comes to that point of steering maybe the spacecraft in some other direction, but it's not considered mitigation methods in case the problems
Michelle?
Yeah, I'd like to know what the sky coverage is of the James Webb Telescope. It varies over the year, course of the year.
Sky coverage means over its lifetime, or you
Right.
usually
The
feel
heavens,
it?
like the full stare, celestial stare.
Yeah, I'm having a hard time just seeing the year.
Oh, sorry. I can repeat the question. So how much of the celestial sphere can the telescope image, essentially? And does that vary throughout the year?
Yeah, it does. As you saw with the orbital mechanics, of course, it's always in pointing away from the Earth-Sun ray. So essentially, it's always pointing away. Of course, it can look into that half hemisphere fairly well, and perhaps even beyond some of it. But because it's always pointing in this way, it's not pointing in all directions all at once. So it does vary throughout the year. It's the ability to image portion of the sky.
Okay. We have a couple more online questions. Robert Rorat asks, how many stars can be analyzed and processed at the same time for the existence of exoplanets?
That's a good question. I don't have the answer to that. Finding an exoplanet is much more difficult than characterizing it, in a sense, once you know where it is. To find an exoplanet, you have to happen to be witnessing the transit. And for that, you need to guess, okay, where is the transit, where it is. As some other missions might be a bit better to find exoplanets. But once you've found them, knowing when the transit will be, then you can target where, you can image it, and then you can look at its atmosphere. So that's where it's quite powerful. There are statistical methods to look at the data to find them by chance, but it's not the most efficient method. Web time is going to be very precious. So when you bid and you say, I want to observe this, it's not going to be looking for a chance event. It's going to be, you need to know the science, you need to know that this orbit, this planet is going to transit, and you want to characterize it, and you have good reasons for it. So I think that's going to drive what actually the web can look at.
Judy?
Yeah, there's massive amounts of data coming from all of the imaging that is done. Where and how is it stored and accessed?
So there's the SCS TI, so there's a Science Telescope Institute, which is located in Baltimore, which has got the responsibility for NASA to both operate and to essentially the Science Operations Center. Most of the data will be stored, I don't know physically if the cloud services now, but essentially they're carrying most of that. In Canada, the National Research Center, the Oxford Institute, has a Canadian Astronomical Data Center, which is dedicated to capture the data and the observations that we will have with Webb to make sure that we store at least the Canadian portion of the data that we receive. There are all the other repositories, also secondary repositories all over the place. For example, some of the nearest team and FGS team may get access to some of the data for their own purpose.
Okay, we have one more online question here. Ed Radford asks, what happens to Webb and other L2 satellites when they are decommissioned?
I think they stay there. They stay there for as long as they stay there. It's not that stable. So ultimately, they wander away. So I don't know how long it takes, but ultimately they don't stay there. It actually takes some effort to stay in L2. It's not as stable as some of the other Lagrangian points where this medium should be. L2 to me. But I don't know if it's years, tens of years. I don't know. I know for low Earth orbit, because that's mandated by law of the systems in low Earth orbit, we need to be able to decommission them within 25 years or so. but there's the Earth atmosphere that helps to it and down, essentially come back and burn on re-entry. For L2, there's nothing like this. It's out there and it stays there. I admit I don't know if they're going to take a fuel reserve to bring it back. But I doubt it. Sincerely.
Hi, Martin. Ted Wright here. I have a question. It's kind of an engineering question. I was wondering about the fine guidance sensor, I think is what you called it. So what I would understand is that actually helps guide it to where it's trying to point, try to target a particular object. How is the telescope move? Like, does some component of the telescope move, or does the whole scope move, or does the whole vehicle move? How does it all work?
So it's not a steered telescope, a gimbal in a way that you would have, let's say, on a ground-based observatory. It's the whole spacecraft that has to move. So you've got gyroscopes that allow us to steer it slow, gently, essentially keep it in position. So the FGS provides the information that the whole platform need to use to stay locked in the pointing position. So that's how it works, essentially.
Are there any other questions?
It's gyroscopic effects.
We have one more quick question. Can an individual get time on the James Webb telescope?
Everyone it's open for everyone to bid. I'm not sure you're not going to get funded. If you get funded, at least you get the Canadian Space Agency financial support. If you get observing time, you need to be associated with a academic institution. So that's one of the conditions. Could be a student, could be, of course, a professor or some sort. To get observing time, what you need is a good proposal. So I did not submit, so I don't know for sure. But if you have a good proposal, you have a good proposal. It's a double-blind peer review. That is, no one knows who submits. No one knows the name. No one knows if it's a man or woman. It's double-blind. It's essentially they look at the text, and if you have a great text and a good idea, and the community that evaluates it thinks it's the thing to do with the precious hours of web, you get time. Now what you do and what you do with the imagery after that, and what software you use, etc. But we got, surprisingly in this call, because of the double blind procedure, we got a fairly high number of postdoctoral students and even PhDs that got time so in Canada. So typically we almost get no one to get time at those level of tuition. But in case of web, because of the double blind, we got new entrants into the field of astronomy that were able to have pretty good pitch and get selected.
So Martin, just on behalf of the RASC Winnipeg Center and the RASC Mississauga Center, we just want to say thank you very much. That was an excellent presentation on Canada's contributions and where the science is going with James Webb Space Telescope. So again, thank you very much on behalf of everybody. And I just want to say to a few other people, thank you for tonight. Ed and Scott here at Winnipeg Center worked hard together to put this together, and then Randy Atwood at the Mississauga Center as well. So if everyone could just, as best you can, please a round of applause for all work. And despite a few glitches, we were able to make it happen. And again there, thank you very much, Martin. And we wish you all the best in your role at the CSA. Thank you very much.
Thank you.
We'll be signing off in the Zoom in just a moment. I just want to remind the Winnipeg Center folks we're going to take a 15-minute break. So at approximately, I'll say 20 to 9, we will start up again. Just please sign back in again to remind everyone that it is our we have bylaws to vote on tonight, as well as our regular meeting information and a few presentations that we're doing tonight. So again, Mississauga Center, have a great night, and thank you for joining us. Good night. There you go. Everybody, get up, stretch, use the washroom. You want to visit? Oh, that's great.
Kind of just, pretty much, takes a while to get back into it. Yeah. We're up to around 35 or 40 here tonight. Yeah. Got another 20 or 30 to go now. We're up to full time. Yeah.
You have a full hour.
Yeah, I went out for 2 nights. Something going on Sunday night. It was just as well because the first night, Friday night, was just pretty nice. Saturday night, clear, but smoke.
Okay. So you see some red? Nice. Because I looked at the people like professionals who take photos of it, and you can really see the oxygen in the middle of a sea of red.
Yeah, well, that kind of also blew it away.
So I still haven't found out why.
It was nice while it was sort of off in the north. Once I got over it, covered about half the sky. It didn't have a lot of character. It was just blob. How are you? Floating around there, so I
Yeah.
Yeah, it was great, all right.
Yes. Did you buy a lithium-ion? Yeah. So the 57. Did you buy the 57 or the 57?
Great ideas and
amp hours?
things like that.
10 amp hours, so it's it will live. But you also had some from you and Steve.
Jason.
Yeah, so I was with you. Yeah. So can you confirm? This is Tina, my wife.
What are you doing with those?
That's
What are you doing with those?
Yeah, we spent the weekend together.
I've only got 2 of them.
Tina two. I need a time to Marlo. Or more. Yeah. No, I would take photos. I never looked at my telescope. I refuse to. I want to take photos and capture it forever.
One of the things that just came up says, can't hear Dennis. Okay. Oh, is the microphone flashing? Press the red button.
I've just pushed the red button. Mike and them, can you now hear me? Let's see. Can you hear me?
It's about an 8-second delay.
For those out there, I'm just waiting to see on the Zoom world if you can just let us know through the chat whether you can see us or hear us. Dennis will do the countdown once more.
Sing something.
Well, I'd rather not, but... Yo, the fire's light for me. September 19th is right around the corner, if you didn't know, International Talk Like a Fire Day.
So microphone,
I don't know, I'm not seeing this microphone on there.
yeah. Is it unplugged maybe?
All right, so we're going to try it. Looks like it's on there.
No, I can't hear you.
Okay.
So Dennis is going to do the countdown.
Oh, good.
Everybody
They can
hear?
hear us. Okay.
All right. So I'm going to start at the beginning again, unfortunately. So Dennis Lyons, for those who don't know me, I'm the president of Winnipeg Center RASC. And I am going to call a special meeting is being called to order to deal with the proposed draft bylaws, or revisions to the bylaw. The way it's going to work is if you wish to speak to the bylaw, the amendment, you will have 3 minutes, and only 3 minutes. Once your 3 minutes mark is up, I will cut you off. And that's, once I feel there's no more discussion, we will move to the vote. The vote online will be by poll, correct? Ed? So like last time, there'll be a poll. For those in the room, it will be by a show of hands. In order to vote, whether online or here in the in-person meeting, you must be a member in good standing. And that means you have to have your dues paid up. You can't be in arrears. So if you're in arrears, don't vote. That's the easiest way to do it. And then what I'm going to do to start it off is I'm going to ask for Judy to come up. Judy was the chair of the bylaw committee, review committee, and she's just going to speak to it briefly, and then we'll open it up for discussion. Judy.
Thanks, Dennis. So we struck a committee essentially immediately after the vote at the AGM in January, after I volunteered to chair said committee. And we had 2 members of the center and 2 members of council plus me. So Michelle was on the committee, and Scott Young, and Catherine Lee, and Cliff Levi, and I. And I think we met 8 or 10 times, drove Jay crazy, going back over bylaws. And we took every comment that we had received during the meeting and in written feedback form from every member, and we debated, talked, revised, suggested, and then went back over it multiple times to make sure all the changes were meshing with one another and consistent. And then we had to change some articles, so we added a bunch of definitions, we clarified some of the processes, we added processes that were missing, we specified membership, we specified many changes and processes in there, and linked with the policy and procedure manual. And so what you have seen online posted, I printed off. That's the first copy I ever printed, just to see what it looked like. And it doesn't read too badly. I think the language in it is much more clear, but we're hoping that you are happy with the changes that we have proposed. Okay?
So before we open up the floor, I just again want to thank Judy and her committee for the large amount of time that they put into this, and I appreciate all that, so thank you very much. So just because it's easier, because I can see you, this group first, I will ask for in person here, does anybody wish to speak to the motion? Ron?
Don't we have to dissolve the old ones before
No.
voting into new ones?
No. When these ones are voted in, the other ones cease to exist.
Okay.
Scott?
Do I have to speak into that? No, I think because I have a computer. So I was one of the rabble rousers of the January Okay, so the quick repeat was, I didn't like the old ones, I like these ones. Done.
Thank you very much, Scott. Michelle.
I'd like to say here.
And Michelle says here, here. Are there any others from in here? Because if not, we're going to move to see what's on the, Ed, can you just look on there? And we'll see who wants to speak online. So we're looking for those that are in on the Zoom meeting. If you're interested in speaking online, please let us know. I'm going to ask one more time, or two more times. Are there any other people that wish to speak on the bylaw? So somebody's just clarifying what I answered there.
Yeah.
And I'll ask one more time, both on Zoom and in the room. For any others? Okay. All right, so now we're going to move to the voting. So first we're going to do, I'm just going to let Ed get them set up on Zoom for the poll. And the bylaw question, just so everybody knows what it is, I'm going to read it so everybody in the room here knows what those outside are seeing. The question is on the ratification of the revised bylaw number 1 of the RASC Winnipeg Centre, for which notification was sent to the membership on July 19, 2022. Please select your vote now on whether you are in favor or opposed. So it's in favor or opposed. And just a technicality, I'm sorry, forgot to officially say, Judy, as the chair of the committee, has moved the motion, and I believe Ed will be the seconder. So just, sorry, I forgot to say that at the beginning, just for clarification. It's important. We are working on bylaws, so we try to follow procedures. So at this point, Ed, if you want to launch that there, and that'll, while we're voting here, that'll give them a few minutes to do it there. So for those in the room, I'm going to say those in favor, please raise your right hand.
Could you repeat that, please?
Those in favor?
No, what's that? I can't read it.
Oh, I just read it.
Yeah, I know.
All right, I'll read the question again. Let me do the vote count first, and I'll read that.
Oh, well, that's...
Okay, well, the vote is, the question is on the ratification of the revised bylaw number 1 of the RASC Winnipeg Centre, for which notification was sent to the membership on July 19, 2022. Please select your vote now on whether you're in favor or opposed. So again, for those in the room, those in favor, please raise your hand. So I have a count of 22 in the room, not counting myself. Those opposed, please raise your hand. There are no opposed in the room. Online, just hit end poll, please. That way it's official. So online, 11 voted in favor and none opposed. 11 out of 11 that are on the poll. So the motion is carried. The new bylaw is in effect. Thank you very much to everyone. We'll now, I will now adjourn the special meeting for the bylaw and open our regular RASC meeting, and we'll just get our slide up again. Okay. So, all right. If we didn't have a technical issue, we wouldn't be in the modern age. The only good thing is I know when on the national council meetings, everybody talks about all the fun they have with all our technology working so well. All right. So most of the lights a little bit? Sure. So again, this is primarily the agenda that's for the meeting. So we've done our Zoom meeting, had a main presentation, break. I'm going to go into announcements in a second. We've done the bylaw ratification. We're going to do do some recognition of volunteers, and what's up, what's new, what's up, Brian Stock will be presenting, and then what's new is Dr. Michelle Boyce. So announcements. So the bylaw, we've done the vote. Just so that we know, along with the development of the bylaw, we were also working on financial policies and other policies. There is an official financial policy that is in place and has been adopted by the council, and have you posted that yet?
I don't believe so.
No, so it will get posted to the members' site on the website. Groups.io rollout, just a quick poll. For all those that are members in the room, which seem to be most everybody, because most everybody voted, has everybody received an invitation on groups.io? Because we've moved off the old RASC list, and we now have groups.io as our primary means of communication. If somebody in the room doesn't know about it, are you on it? Yeah, so we're just checking here because we're slowly going through, and the way that works, just so everybody knows, is it's based on the national list. So once you're registered, so for instance, earlier tonight, there was somebody who talked to me, John I think it was, and joined about a week ago, and was wondering how he could get some information on access to the website and that. And I just explained that what happens, we have to wait till national gets you on the national list, and then we have access to your name, and then we can add you to our list. So it takes probably 1 to 2 weeks, because we're all volunteers. It just depends on when they have the time to take a look. So that's our primary means of communication. And in there are several subgroups, binocular interest group, buy and sell, things like that that are going. And that is our primary means of communication and sharing information with the club. You have a choice to opt in or out. The main list that only really members of council can post to, you can opt out of that because that's how we're going to present information to you. So things that are of club nature, that are center nature. Does anybody have any questions on that? Go ahead.
Is there a link from the RASC website to groups.io?
No, I don't believe so.
Should now be done at some point.
I think Russell is making that, Russell and Mark Saracen are making a link and putting instructions directly on the website.
Okay, and that link will probably be in the member site.
In the member site.
On the member site, so you have to log into the site as a member. Because groups.io is just for members. Again, we're always looking for volunteers for meeting presenters. I just want to remind everybody that the loaner scope coordinator is Mike Fracas, and we have lots of scopes. And we're getting into a better seeing season, where it's a little darker sooner. First Fridays at the Manitoba Museum. I just want to remind everybody again that Scott also works at the museum, and we've been invited to come down on the first Fridays. The next one will be in October, and we're all welcome to come down. Just Scott asked that if we let him know you're coming and what type of scope you're bringing, that way he's got an idea of how many people are coming, and you can prepare, because they try to have snacks and things like that for the volunteers that come down to the museum. So the museum still has a mask policy, Scott?
The mask policy actually just ended. It's recommended but not required.
Okay, so recommended but not required while we're down there assisting and working with one of our like-minded partners. September meeting. Again, I want to just say thank you again to the Manitoba Museum for supporting the previous event. We couldn't have done it. Sprucewood Star Party. Just want to recognize Sylvia Graca and her team who put on another excellent weekend. She kind of announced that she was retiring, and I think that's what brought all those Aurora happening for the weekend. So that's probably what happened. She should have waited till the weekend was over. But again, I want to thank her and all her team for putting on an excellent weekend. Again, there's usually 60 to 70 people there, and that's what we had. But we also had the recognition for the for the Spruce Woods to become recognized as Manitoba's first dark sky preserve. So Tim and Sandy Just stand up for a second so people can know who you are. These two folks put incredible hours. Incredible hours, endured a lot of incredible bureaucracy, both from Manitoba Parks as well as the RASC Light Abatement Committee, but persevered, and we now have a dark sky preserve officially in Manitoba. So thank you again for all that work. Part of that evening was a Sunday evening. We had a public outreach, and depending on how you want to count the numbers, it was anywhere between 250 400 people that were there. The mosquitoes, which normally come out in that public event, never came out. There was folks to scopes till about 11 o'clock, I believe, if I'm not mistaken, that were there. So it was just an incredible evening for that. We had lots of moon, we had lots of aurora, and as well, Jerry did an excellent job, as well as he always did, on giving a sky tour. In fact, we had a comment come into our website, I believe it was, just a person who had paddled downriver. They kind of knew about the event, and they had to comment publicly about Jerry's outstanding skill in sharing his knowledge about the sky with that group of people. So again, thank you to Jerry. He's not here, I don't know if he's online, but thank you. So Jerry, hey. Whether you realize it or not, January, oh sorry, go ahead, Michelle.
Are there any plans, like a lot of people show up, are there any plans to keep that momentum going?
Which momentum, sorry?
Well, almost somewhere around 300 people from the public showed up, so I'm thinking there should be some kind of annual.
Well, okay, just so you know, every year there is usually a month before Spruce Woods, our Spruce Woods Star Party, there's a public event. That's why I made the comment about mosquitoes every time I've gone. You know, as soon as 9 o'clock, it's like there's so many mosquitoes, people will take one look in a scope and then they're gone. But this year it was incredible. There just wasn't any bugs. It was warm. People, what really made most people leave around 10 o'clock is it started getting cooler and they were in short t-shirts. So, and then the other thing too, we need to recognize that the Brandon Astronomy Club puts on regular events there. They did 4 night hikes out there during the summer and several other things. So our sister club, Brandon, does a lot of work locally there. And that's part of the reason why I think it was such a good turnout, to be honest with you.
Yeah, I talked to the one window.
Yeah, Stan?
I want to make a comment. Speaking to some of the people who work there, they say that when they finally find out the date that the public event will be done, and they post it on the provincial park guideline, that date very quickly, the whole campground gets booked up. So a lot of people look specifically for that event.
Yeah. Okay. And Trevor? No, it's not Trevor. Who's out there? Trevor?
Yeah.
Trevor's the one who does all the coordination. Trevor will be posting when there's events that we plan to do so that other members, if we wish to travel out there, can join them for those events and help them in showing the night skies to the crowd. Dark Sky Preserves, it's not over yet. There's also the Nature Conservancy of Canada has reached out again to us. They're very keen on trying to get things going out at the Stewartburn area. So that's the last question they gave me was, how big can they make it? So that's a positive sign. And we'll be looking for, we'll put notices out when we need volunteers to go down there for the same thing. We usually do a public event and promote the sky to get the local community on side.
Dennis?
Yes.
Tim here. Just in case I'm out of line here, I brought a little item for you in case you forgot.
Oh, that's right after the announcement.
Sorry, thank you.
You haven't forgotten. Thank you for the reminder. So, the last thing I just want to talk about is Glen Lane. The dome is still closed, but the warm room pads are all open, power's on. Everyone's welcome. Tomorrow night is technically our members' night. It is a full moon, but we'll see what the weather forecast is for tomorrow. And if there's going to be nobody out there, we'll let you know by email. Yes?
Is there a porta potty?
Pardon me?
Is there a porta potty?
There is supposed to be a porta potty on site. Okay? Jake?
What's happening with the whole Kamek relationship? Is that starting up again? Or?
Yes, so the OCAN, I haven't talked directly to them, but they are advertising their astronomy night starting on the 15th of this month. For those who don't know, we're invited as members of the RASC to bring our telescopes there for their event up on the roof, viewing event. And I didn't notice what time it starts, but usually what happens is the event, I'm just going to guess it starts at 8 o'clock. It's free admission for RASC members if you bring a scope for the public viewing. Okay, if you don't, then you have to pay the admission fee to come in. I think it's $10 a person. And I'm not sure which it is, but if you're interested, we'll start posting that on the web as well, on the main group, groups.io site. Any other questions before I move on to something? Okay. Let's see if these lights will turn on. If I can read this. Tim, I don't know if I can do it quite as dramatically as I did there.
Look it like that.
Oh, yeah.
Can I
We
put
need
the lights
light.
on just for a moment, folks?
We need those eyes.
No, the lights ain't coming on. I'll do my best here. There. Probably ought to do the camera too. That's okay? Here we go. I don't know if they can see me. Imagine, if you will, a place in a galaxy not too far from here. An evening under a dark sky where lasers could be seen in the distance and the deep rumblings of the evil Darth Jerry planning the conquest of the galaxy. Our intrepid adventurers, Tim Solo Kennedy, Sandy Chewbacca Shuchuk, debated how to protect this patch of the galaxy's pristine dark sky. From this point forward, it became known as the Dark Years Battle. The two knew to achieve this honorable goal, they would need help over the eons. They gathered around them Ron Boba Fett Berard, Mike the Klingon Caracas, Queen Gale the Wise, Marnie, don't step there, Dangerfield, Gord the Hutt Tulloch, Scott the Universe Young, Cliff the Seer Levi, and Master Jedi Lindsay Price, who is with the Force now. Many others of the secret RASC Winnipeg Council were recruited to free the dark sky. Their endeavors led to epic battles with the insidious bureaucracy of both friend and foe. Early on, support grew within the keepers of what is now known as Spruce Woods, or in the native tongue, Kitchi Manitou. Even when it seemed the very waters of this peaceful point in the galaxy was against them, they prevailed. And Spruce Woods Provincial Park is now a dark sky preserve under the protection of many. The story is not over, but has just begun, as the wonders of the night are always under distress. Will you join us in thanking our two lead heroes, Tim Solo Sweeney and Sandy Chewbacca Shuchuk? And I'll ask Sandy to come down, please. We have a presentation for you. And Tim, you want to come down too?
I've received mine. That's
Okay,
Okay.
keep going.
I received mine at the event.
Tim's already received his. So Sandy, on behalf of the RASC Winnipeg Center, we'd like to present you with this thank you for all the work you did on making Spruce Woods Provincial Park a Dark Sky Preserve.
Wow. Take your mask off.
Take your mask off?
Yeah, don't mind.
What's your best?
Yes. Shouldn't say something.
Can we, you want to get one with the two of them?
Do you want to say something?
Well, I'm just going to say thank you very much. Thank you so much. This is a huge honor. Yeah, I don't really know what to say. It took like 13 years, and I guess I have gray hair now, but that's probably from working with Tim. But yeah, I'm happy, really happy for the park, most of all. It's a great achievement for them. And it's been Dennis, you named everyone that worked so hard on this, all the RASC members. It's really been my privilege to work together with such wonderful and talented people. So, yeah, thank you very much, and yeah, let's protect and enjoy the Dark Sky Preserve. Yeah, thanks.
Sandy, could you put that somewhere so that people can see it at the end of the
Oh,
meeting?
absolutely, yeah.
No, it's mine.
Also,
Brian.
I wanted to point out that I'm sitting beside the gentleman who took those awesome pictures. There's 3 of those plaques for loose, and they're just incredible. The one at the park just blows them away. Everybody who comes, you know, that was like,
All right, so Brian, go. Thank you. And Brian is going to come up, and we have another presentation to make. So.
Thank you, Dennis. Really? Okay. Okay, so. Let's see this is. All right, I got 2 awards to be given out. I'm determined of the award to be called. That would help. Okay, as chairperson of the awards committee, I have 2 awards that have been given out. The purpose of the committee now is so we don't miss any special people that have outstanding service or achievement they've done. So this is for the awards for 2021. I'm going to start off with Trevor Bryant because he's not here. Probably not Brendan. He said he would be watching by Zoom. So he's going to receive the RASC Outstanding Achievement for 2021. Okay, so what I have for Trevor, so this is a award for outstanding achievement for the work he has done here, especially for outside the Winnipeg area, especially around Brandon. He joined the RASC back in 2003. He was part of the Brandon Astronomy Group who organized events for the elementary school as well as the local Brandon 4-H club. He is now currently the president of the Brandon Astronomy Club. He's done numerous amounts of public events in Manitoba. One notably was 2017, which I was there, when he was part of the Riding Mountain National Park's first Dark Sky Weekend. That was a nice little weekend, it was a long weekend. There's other things he's mentioned, I'm just going to keep it brief, but especially Tim just mentioned this now. He's done a number of workshops for Jennifer Bryson, the interpreter out in Spruce Woods. So let's give him a round of applause for Trevor Bryant. Okay, so the next one is for Gord. Gord, you're going to have to step down. Sorry. For the pictures. Okay. This was an easy one. Okay.
I work with Gord as being president, and so, and being past president on the council. He's done a number of work here, so it's with great pleasure to present the award, Gord Tulloch, for outstanding services that he's done for the club. This is an award for people who went a long way providing excellent service to RASC Winnipeg Centre, to the members, to the council, and as well to the general public. I'll get in greater details about that. Gord, I don't know what you do, because do you have time to sleep? Because it doesn't look like it, especially with your hobby. Okay, so I added some lists to this. I'm going to keep it on file. It started back, well, you said this is your second time, but he started with the revamp of the webpage. So I'm very grateful for him for doing that for me and continuing on with other members on the council. He's also, later on, he joined as the council as vice president, which I appreciate that. And to mention some of the things that he's done, and this is not all of it. Of course, the webmaster from 2018 to 2022, membership coordinators, beginner's package, especially the newsletter editor in 2019. I put in brackets, you redefined Winnicentric. You did an excellent job on that. And you also mentioned about archiving the old Winnicentric, I believe, a couple of years ago. Yes. So again, contribution he's done. Of course, he represented the club for media interviews, frequent presenter for the Star Party and for the RSC Club. I do thank him for that. Strategic plan for the center. He wrote most of the initial draft of the bylaws and the policy procedures, as well as other council documents. And just one other thing I'm going to mention about was the Telescope for Kids program. So that's definitely something. I can get to my next notes here. All right. Okay, Telescope for Kids coordinator awarded 8 telescopes for kids from 2020 and 2021. That's given back to the community. The kids really did enjoy those telescopes, and I know we changed our lives, especially around Christmas times when it was a gift. But that was an excellent idea, Gord. So I do appreciate that. And of course, I have to mention about this, and this is where I'm going to file this away. The Google Drive, where we have a database now, thanks to for Gord. Now we have a database where we store all our documents for now and for future council members. So we're always going to have something. So let's give Gord a round of applause for his outstanding services.
It's me and Chewy. Well, I just wanted to say thank you for the recognition. It's always nice to be recognized. I don't think there's anyone in the club who can't make a contribution and make a huge contribution. And I guess, as I've always said, I keep saying it, is you know, the club is only as good as the contributions from its members. And I think everybody in the club, there's 230 odd members in the club, everybody in the club can make a small contribution and make, you know, many hands make light work. So definitely the reality is generally that very few people are carrying most of the work, most of the load. And that's how you end up with 10 different jobs in the club. But I think everybody, and I'm hoping everybody who's listening and anybody who's reading the newsletter will think about, and you know, the services that you can do to the club, the services you can do to the community, and pitch in and help out. And you know, recognition is fantastic, but there's a lot of satisfaction in actually doing things for the club and doing things for the public, going out there, doing you know, outreach. you know, you can see the faces of the kids you hand the telescope to, you know, all the upturned faces you see when you're running a star party type thing. It's really rewarding, and I encourage everybody to contribute to the club, because it's a great thing to do. It's a great thing for yourself. It's a great thing for everybody. So thank you so much for this.
There were lots of applause icons for both of our awards.
All right. And Gord says so nicely. Here's a few positions that are available that will be looking for volunteers. So the 1st of January will be the AGM. So a couple things. One, if you have interest in being on council, Brian is the chair of the nominating committee. So let himself know if you're interested. As well, if you've got any interest in any of these different positions, meeting coordinator, volunteer coordinator, explore the universe, webmaster, mentor coordinator, meeting presenter, finance committee, observatory committee, light abatement, awards, and nominating committee. And the one that we mentioned earlier today already was the Spruce Wood Star Park Committee. And primarily the role there is to work with the chair to plan and deliver the Star Party. At the next meeting, we will probably announce who the new chair of that committee will be once we make a final decision on council. Mentioned members observing night already. And now Brian, up for what's up. Don't ask me to turn them back on.
Yes. So this is for what's up for September the 22nd. Well, I gotta stand here because of the other mic. Okay. So that's the, as Dennis has mentioned, that's the Aurora for the Star Party. It happened on Saturday. That's Jerry's Dark Sky Tour. It was really great. So we had 2 shows going almost at the same time. All right, so does that work? What's up? Okay. Okay, let's start off with the planets here. It's quite simple. Okay, so Mercury is not going to be really visible during this month. Same thing for Venus. It is going to be a morning planet, but it would be really close to the sun. Mars is going to rise just before midnight, and it's in the retro motion, I believe, and its magnitude is going to increase. Jupiter is going to be in its opposition on 26. So, and the moon's going to be spread out pretty much, but I'll explain that more in greater detail. And Saturn, of course, is going to rise before sunrise. So again, it's well placed for observation. Those 2 planets are going to be great for viewing. But Saturn is moving away from us. Okay, so what do we have for September events? Pretty much the same from last month. Some of the planets are going to be like a few degrees off the moon. We do have the fall equinox, and September the 22nd. The new moon is going to be on the 25th. And of course, the Jupiter opposition, or the closest point it's going to reach, is on September the 26th. All right. So as I mentioned before, Venus is going to be kind of close to the sun, so in the morning it would not be advisable to really view Venus. Now for Jupiter, I was actually out there last month on August the 15th, something like that, to watch Saturn being the closest approach. So that was quite nice to see Saturn. Now we have Jupiter on the 26th though. So now is probably a good time to view Jupiter. As you can see here on the bottom screen, I'm trying to show what the moons are going to be like. One that's not highlighted is Europa, but as you can see here, Jupiter and Saturn are going to be visible throughout the night. And of course, on 26th, the closest approach. So it would be advisable if you go and have a look at it, visually or photography if you want. Now, this is an example of Mars I have here. And I also mentioned about Orion. Orion's one of my favorite constellations, because when I started off in astronomy, it was like one of the first targets I did, with a 3-inch reflector, which is not great. Learned a lot after that, and never get a department store telescope. Okay, so just kind of mentioned Orion's going to start rising around a little after 2 o'clock. Of course, we have Mars is going to be just a few degrees, 4 degrees off the moon. And of course, it will be next to Pleiades. So that'll be interesting on September 17th. Okay, so I want to just touch on a few constellations I have up here. Of course, we have Orion, we have Pegasus, and Hercules. Hercules was a big topic during the star party, especially M13. I think Michelle kind of mentioned it. So if you're kind of new to astronomy, you can always come see me. I'll help you out with that. So Pegasus, and of course we do have Cygnus directly above still. But yes, we do have a few winter constellations coming up, especially Orion. Okay, now I want to touch a little about the Milky Way. Now, unfortunately, the Milky Way core is fading pretty fast, so that's all you're going to see. By end of September, there could be nothing left of the core. So if you are into photography, like I am, I'm going to try to shoot the core before it disappears entirely. So next, the zodiacal lights is happening, but it's not happening to September the 23rd, which is going to be 2 weeks after that. Unfortunately, it's not going to happen until pre-dawn. So it's not really a good time to observe it, but if you do happen to be up at that time, go check it out. What does it look like? Well, I've seen it for the first time back in Arizona, and it took me a while to see it because it's bigger than you think. And I do have a little picture to represent what it looks like. So it's kind of a triangular point of light there. So it's interesting. It has to be a dark site, so unfortunately. So if you have a dark site and you're able to see it, that'd be great. Go check it out at least once. Visually, you can have a look at it. It's like the Milky Way, almost just as bright as the Milky Way. Now, the solar activity that we have going on, I'm monitoring this every single month. And again, we're blowing the bell curve on this part here. As you can see here, the actual values is blowing the predicted values that we have here. So again, lots of increase of aurora as witnessed over the weekend's star party. And I've got a lot of pictures to prove that once I get it formatted for everyone to view. All right, so what is the weather like? Well, I don't know. I'm kind of questioning it right now because temperature is still pretty good. This changed a couple days. I monitor every night for a week to see what's going to happen in terms of the weather. So you see it looks like a roller coaster ride, as you can tell. So, well, not to worry about the temperature, because it's still going to be pretty warm. What about the cloud coverage? Well, again, it changed a little bit here. So next weekend doesn't look very good. It looks like it's calling for some rain. So, but earlier this weekend, it showed that it was going to be clear, but now it's kind of like, again, we're going to have some clear points, clear breaks in the sky, maybe over the weekend. But as you can see here, on Sunday, we may have something there so far for a couple of days, and then it's going to go back up cloudy, and then it looks like it's going to be some rain over the weekend there. So unfortunately, that's all I have for the news for the weather. So that's it. So that's what's up for the sky, or what's up for the sky for September the 22nd. Thank you.
Thank you, Brian, and we welcome Dr. Michelle Boyce to come on up, and she'll talk about what to do.
Okay, I guess this What's New is slightly an homage to the Star Party this weekend, because we highest resolution of the sun taken yet. This is 18-kilometer resolution, and it was taken by INU Solar Telescope, aka the Daniel K. INU Solar Telescope, formerly known as the Advanced Solar Telescope. It's the world's largest solar telescope, about 4 meters across, and as I mentioned, 18-kilometer resolution. So you can see this 82,000 hash of the sun, and here's the Earth below just for scale. The telescope is near completion. It was supposed to be completed a year ago, even during COVID, but COVID basically has delayed the telescope. So right now it's going through still some commissioning phases. So I expect this will be much more fantastic. And the basic science behind a lot of observing the sun is to try to understand the sun and get a sense of space weather prediction. Because if we get solar flares and stuff, these particles eventually make it to the Earth and make it to our satellites and can even affect electrical systems. I believe there was some time back there was a power outage in Quebec due to a solar event. It had something to do with how the hydro lines were distributed throughout the province. That's what I guess. Just a quick reminder of the solar basics. We have the core of the sun here. The mouth. Can you see the mouth? Oh, I don't know laser before me. So the red thing in the center is the core. The next layer out is the radiation zone. The core is where hydrogen is converted into helium. A lot of energy zips out through there and is transferred into the next layer, which is the convection zone. Just above that is the photosphere. And that is the point at which light leaves the sun, where we can see. We can't see any further down, so we can only see. We have accessibility at that point in terms of visual observation. And above that is what's known as the chromosphere, which is where the hydrogen alpha telescopes are done. So the solar observing group that we have has hydrogen alpha equipment, and if you look there, so there's various features such as specules, sunspots, and prominences. So that's what I have here: photosphere, chromosphere, and then there's a transition zone, which then goes to the corona, which you can see during solar eclipses. So this is just sort of the telescope itself. It's sitting in Hawaii, on top of a high mountain in Maui, Maui, I believe. And this is a picture of the mirror that's used, the 4-meter mirror. So this is after successful illuminization. And this is the actual telescope harness with the mirror shown in here. So earlier images, you may have remembered this image of the solar granules that came from that telescope pre-pandemic. And you can see all these little, what's called granulation. And really, it's almost like if you have a pot of water and you're boiling it, you get these bubbles come up. So it's a similar process. So if we look at the sun, we have the core radiation being transferred to the core, and then the outer layer here, we still those circles. That's the line, which is this is a thin zone between the radiation and convection zone. And that's where this magic takes place. And so you can see here at a solar minimum, you have these lines, and as the sun rotates, these magnetic forces rotate, and they get twisted up. And so they form these flux tubes in the sun. So you can imagine there's a flux tubes inside the convection zone, down by the taproom line. And then some of those flux tubes end up undulating to the surface, and they emerge through the surface, and this is where you get the sunspots. The sunspots always come in pairs. Well, I should say, naively they come in pairs. They more come in clusters of south and north poles. So there's always like two patches where the fields are going in and exiting. And that tends to carry gas and stuff that gives you these prominences. And so right where it exits, it's actually cooler there. Not by a lot, but cool enough that that's why you see this darkening. Okay? It's still pretty hot, but it's not much of a temperature difference to give you that contrasting effect. And I mean, these are great images, but you can get some pretty good images with your own equipment, so you can enjoy the sun too. And this is just some examples of images I took last year. And with that,
Any questions? Are there any questions online, Scott?
Just some thank yous.
All right, great. Thank you very much. Okay, so we've come to the end of the meeting. Somebody else turn the lights on because I don't know. And I just want to say thank you to everyone for coming out tonight. Thank you to those on the Zoom call. Thank you all for being engaged in the vote on the bylaw. And Sandy and Tim are here. Please take a moment to go over and thank them personally for their great work on the Dark Sky Preserve at Spruce Woods Provincial Park. And Sandy's left the picture up here for you to take a look. And again, also Ron was our photographer and the person who did the mounting. So thank you very much. For those that are interested, Boston Pizza is on again. For those that want to go over to the Boston Pizza after the meeting. And with that, I will call